Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem consecutives ones not allowed. So this is a medium level problem and it's a problem of the day on Geeks for Geeks. And the company tags of this question are Flipkart, Morgan Stanley, Microsoft and Snapdeal. And the topic tags are arrays, dynamics programming and data structures and algorithms. Fine. So let us go through the question now. Given a positive integer n, count all possible distinct binary strings of length n. Okay, so this n signifies the length of the binary string such that there are no consecutive ones. The string that you're trying to form using the bits, like it's a binary string, so you'll be using the characters like 0 and 1. So the condition, it has been prescribed that no consecutive ones must be there. That means you cannot put ones to each beside each other in the string that you're trying to form. Output your answer modulo 10 power 9 plus 7 because it might be so, like there might be many possibilities that long cannot hold it. So that is the reason you need to take the modulo by 10 power 9 plus 7. So these are some examples given, and the time complexity expectation is O of n and the space complexity expectation is O of n. So we'll be solving using a solution like that is taking a constant space like O of 1 and the time complexity is O of n. Okay, and n goes up to 10 power 5. So we are going to see a space optimized solution, and yes, n goes up to 10 power 5. So let us now understand this example. The very first example, n equal to 3, the output is 5. Why is it so? So n equal to 3 in the sense, what does that signify? It is a string of length 3. So we need to find frame a string of length 3. So how many strings are possible? So 0 0 0 0 1 0 1 0 1 0 0 1 0 1. All these strings, if you can notice, there are no ones beside each other, isn't it? There are no consecutive ones. So there's no other string that is possible that you can, if you even if you want to try, you can try it out. Let us assume I'm putting 0 here. So if I'm putting 1, I need to put 0. So 0 1 0 is done. Okay. So let us assume I'm putting 0 this first point, and I'm putting 0 again, and now I can put 1. So 0 0 1. So this is also done, and like that you can even try it out. Only these 5 possibilities will be there. There will be no more possibilities. So fine. So we do not need to output the strings. We only need to output the count. Okay, number of strings possible. So that is the reason in this case answer of like when n equal to 3, the answer is equal to 5. Okay. So I hope you people are understood what are they actually trying to ask and what is the output that we need to give. Fine. Now let us frame the approach. Okay, let us frame the approach. So I'll be taking a general example, like it's a complex example, but to listen, but at the same time, it's very interesting example. Okay, so let us assume you and me. Okay, you and me are given a task to actually construct a train. Okay, construct a train. Yeah, you heard it right. Construct a train. I've taken a weird example, but I feel like if you actually deal with an example for a longer amount of time, you'll exactly remember the intuition, or you'll grasp the intuition. That is my main idea behind taking this. Construct a train. Okay, so that construct a train, the train consists of two types of compartments. Okay, goods compartment and passengers compartment. So it's a weird type of train. You do not usually find this, right? Goods and passengers compartments to be in the same train, you do not find it, but we are going to construct a train like that. Goods compartment and passengers compartment, both will be there in a single train. Okay, so that is our goal. But there is one constraint. What is that? No passengers compartment, no passengers compartment must be beside each other, must be beside each other. Okay, must be beside each other. This is the constraint that has been given. All right, so now you have been given this task and I was also given this task. Let us assume you're starting to build the train. Okay, you're starting to construct the train. Okay, so by taking the first compartment as goods compartment. Okay, let us assume this is the goods compartment. I'm very bad at drawing, I can accept that. You people need not judge me again. Okay, so this is the goods goods compartment that you have started, and I have started with the passenger compartment. Okay, so I have put the wheels on the compartment. So this is passenger. So passenger compartment. Okay, now there are compartments available. Goods compartments are available here, many, and even passenger compartments are available here. You just need to pull them and just join them with whatever machinery. That's not needed here. So goods compartment is there and passenger compartment is there. Now you are trying to construct the train following by keeping this constraint in mind. Okay, keeping this constraint in note. For you, what are the available two options for you to construct? You can either put a goods compartment here next to this. You can either put a goods compartment next to this, or you can put a passenger compartment next to this, isn't it? You can put both of this. You can have the choice of choosing any one of them. But can I put a passenger compartment here? Can I put a passenger compartment here? No, this is not acceptable, because according to the constraint that has been given, no passenger compartment must be beside each other. So for me, what is the only option that is there? Only goods compartment. Okay, I can only place goods compartment here. Okay, I can only place goods compartment. I cannot place passenger compartment. But in case of this particular goods compartment, you can, if you're starting at this point, you can put a goods compartment or you can put a passenger compartment. I hope you people are getting. So in this case, goods, like only goods can go up here. Okay, goods can go up here. Goods can come here to the passenger, and goods can come to the goods as well. But passenger can only go to that point which has the present thing to be goods. Okay, passenger compartment cannot join the new passenger. Let us assume this is the new one. This cannot be joined to the train that we have constructed so far, which has the last one to be passenger. So this passenger cannot be joined with this. Okay, let us assume this is the last one. Okay, till now this is the only one we have constructed, but let us assume this is the last one we have constructed. Okay, last one in the sense previous one. Now we are trying to join the new one. So these are the new one, this is the old one. Okay, so if it is a passenger compartment at the last in the train that we have constructed so far, then I cannot put a new passenger compartment to it. But if it is a goods that has been constructed so far, like this is the old, okay, so if it's a goods that is at the last that has been constructed in the train that we have constructed so far, then I can put the new goods or new passenger. Both of them are like can be placed. Okay, I hope you people are understanding this particular analogy here. So what I'm stressing on it is, so whatever the number, okay, whatever the choice that I have, so goods new, okay, for goods new I can go, okay, so goods new, once I join this goods new, once I got join this new compartment of goods, okay, so that can be joined to what are two options are there. I can join that with goods old and passengers old. Okay, goods old and passenger old. And what about the passenger new compartment? So I can only join that with the passenger old. Okay, and now once you join, okay, let us assume I'm just erasing this particular things. I'll just erase this stuff so that it will get it will avoid any sort of confusion. Now let us assume I've joined this particular with passenger, let us assume, and this with goods. Okay, this only option is there for here, it's goods. Now after that, what is your old ones? Now this would be your old ones, right? This will be your I'll just mention it, this will be your old ones. Now you'll be again trying to look out for new ones, isn't it? Now you'll be again looking out for the new ones to be joined. So now you'll update your goods old will be basically the goods new, right? Goods new. So whatever that you have joined right now, okay, that will be your old one, that will be your previous one. Now you'll be joining the new ones again. So again passenger old will also be equal to passenger new. Okay, so whatever update you have done so far by to new and goods new and passenger new, that will be the old ones now, because now you're trying to do the merging, like now you're trying to add some more compartments. Okay, now you're standing on this, till now you have stood on this, now you're standing on this particular position. Okay, now you have come to a current position, and your current will now be the previous, so that other current you can join. When will you till what point will you go? This whole procedure will go on till n. Okay, till you get a size of, till we get the size of n, But why am I telling all these goods and passengers? Replace passengers with 1 and goods with 0. Okay, so that is what the question says. So it's a string like this. This is what you need to construct. Let us assume you need to construct a string of n equal to 6. And now once you are placing 0, okay, now once you're placing 0, what are the available options that you can place here? You can place 1 or you can place 0. But what if you're placing 1 at this point? So I'll just write this again. So once if you're placing 1 at this point, you have only one option. What is that? 0, because you cannot place another 1 here. Passenger cannot be beside each other. You can only place 0. So that's what here. So let us assume 0 to be goods and 1 to be passenger. So here what did I say? 0 can go up to two places. It can either join the goods old or passengers old. Okay, it can good new. This is the goods new. So this is goods old and this is passenger old. So this 0 can either be a part of here or be a part of here. But this one passenger new can only be a part of goods old, right? I hope you people are understanding this particular analogy that I'm stressing so far. So the same thing you'll be replicating in the case of strings. So 1 can only join with the zeros with the string that you have constructed so far, such that the last character is 0, and zeros can only be a part of those strings whose like 0 can be a part of those strings which have 1 at the last character as well as 0 at the last character. Till now you'll be going till the end point. That's it. Once you're done, okay, and you'll be finally returning the possibilities. Because you have started with this, you'll be returning the sum of these two, addition, sum of like construction with 0 and construction with 1. That's it, and you'll be returning it. Okay, I hope you people understood this. So this intuition, firstly, to begin with, you need to start with doing recursion. How do you do the recursion? So let us assume you're starting, like, again, this problem is like this. First you'll be putting 1. Okay, let us assume you're putting you're trying to put 0 or 1. Let us assume you're putting you have put 0, and now the next call would be you'll be checking if your last character is 0, then I can put 1 or 0, both cases. So I can put 1 or 0, and if my last character is 1, if in case I put 1, only possibility is try to only put 0. Okay, so this is how you'll be going on doing the recursion. And what will be the base condition? Once you reach your index, particular index to be equal to n, or that last n in the sense length of this thing, once you have reached this, then you need to return 1, n minus 1, or yeah, anything n. So n minus 1, yeah, n minus 1, you have come to the last. Now you can just check the previous character and update it, and then return 1, because once you have come to this particular position, you can assume that you have completed one successful string where there are no consecutive ones. Okay, so that is the logic. So you can even do the bottom up approach, like you can start from this particular point and then go up here, and you can put a base condition like index equal to 0. So this is the recursion approach. But what if we can try to memorize this particular thing? Like, there are many things that we are recalculating, isn't it? So we can use it 2D vector like 2D dp vector and dp vector, and store all the values. Okay, 2D dp vector, and we can store all the values, put in an index and length. One parameter would be your length of the string that you have constructed so far, and the last character, if it is 1 or 0. If I'm doing the bottom up approach, if I'm putting 1 here, okay, if I'm putting 1 here, and the length of the string, and that is going to vary. And now once again, if you'll be calling 1 here, once again you'll be calling 1 here, and you'll be storing all those value is in your dp vector. Okay, in your 2D dp vector, which has the two parameters, length and the last character, is it 1 or 0. So in that fashion you can complete it, and finally you can add these both, like dp of 0, like if like 0 means that you have successfully come to an end. So dp of n minus 1 of 0 plus dp of n minus 1 and 1. You'll be finding all these things in a lot of editorials. You can find this whole stuff, dp solution, in a lot of editorials. I'm not explaining all those things because it's not really important, because this question can be easily solved just like that if you can actually observe this analogy, right? So it's just that we are only dependent upon the previous values. We need not need the whole dp vector. We are just depending upon the previous values, isn't it? So that is the reason I'm not using any approach that costs a lot of space. We can just solve this in O of 1, as said previously. So it's just that previous old values we are using, and we are updating it to our current, and then the new ones we are welcoming and we are updating it again, that we'll convert it to as the old, and we'll do it so as long as we reach the end. Okay, so that's the only thing. I hope you people understood the analogy here. So we'll just code it up. So initially we'll be taking 4 variables. What are they? Long, prev 0, okay, that is equal to 1, and prev 1, that is also equal to 1. So what does prev 0 and prev 1 indicate? Prev 1 indicates the number of possibilities of string length 1, such that prev 0 is like the string is having the last character as 0, prev 1 is the string is having the last character as 1. Okay, and length is 1. So how many possibilities are there? Only 1, right? Having 0 as the last character will only be one possibility, and having 1 as the last character will only be one possibility. It's of string length 1. Okay, and from length 2 we will start like updating and taking new variables. And current 0, that is when take current 0, so that is also to be 1, and current 1 is equal to 1, and mod equal to 1e9 plus 7. To be honest, you need not take current 0, current 1, you need not initiate it. You can initiate it later, but the reason why I'm writing it is, I'll just explain it once I finish up the code. For length, okay, int length equal to 2. Now you are trying to figure out the number of possibilities as you are increasing the length of your string till length less than or equal to n. Okay, and length plus plus. So once, now if you're trying to add a 0, okay, now if you're trying to add a 0 to your string, where all the position, where all, like, to all what, I mean, what are all the things you can add 0 to? So you can add 0 to this strings ending at 0, as well as strings ending at 1. So new current 0, your current 0 would be actually equal to prev 0 and plus prev 1. Okay, so you can add 0 to all the strings that are ending at, that are having the last character as 0 or 1, and take modulus, and your current 1, where can you add 1 to? You can add 1 to only to those strings that are having the last character as 0. Okay, so that is prev 0, and you could take the mod of it. And now once you have added, those will be your previous, so that you can do the next iteration. So your previous 0 would be equal to your current 0, and previous 1 would be equal to your current 1. Okay, so after this, finally return this current 0 plus current 1 old mod. Okay, you can even write previous 0 plus previous 1. There is no issue, because you are putting these current 0 current 1 values into previous 0 previous 1 values, so it's completely fine. Now why did I write this current 0 initiate current 0 equal to 1 and current 1 to be 1? Because I am writing this, I am using current 0 and current 1 to be to return. So if I do not initiate this to 1 and 1, and if I get some n value to be equal to 1, so in that case I'll not be going to the for loop, so I need to return, right? So for that reason I'm even initiating these to be 1 and 1. So if in case the n equal to 1, then this perfectly works. Okay, so that is one of the reason I've initiated them to be equal to 1. Fine. So I hope you people understood this. So this is all for it. And if you can carefully observe, this is also basically nothing but current 0 is nth Fibonacci number and current 1 is n minus 1th Fibonacci number. So in this case, if you just list down all the Fibonacci numbers 1, 1, 3, 5, 1, 1, 2, 3, 5 and so on. So the very first one will be your 0th Fibonacci number. The second one would be your first Fibonacci number. And then 2 will be your third Fibonacci number. And your like 1, 1, 2 and then 3 would be your fourth Fibonacci number. So when you're actually putting 3 n equal to 3, so you'll be returning Fibonacci nth Fibonacci number plus n minus 1 Fibonacci number. What is nth Fibonacci number? That's equal to 3, and n minus 1, so 3 minus 1 2, so second Fibonacci number, that is 2, so 3 plus 2 equal to 5. So that's the reason output is 5. Even if you consider taking n equal to 4, then you return the sum of fourth Fibonacci number and third Fibonacci number. What is fourth Fibonacci number? 5. Third Fibonacci number 3, so 5 plus 3 equal to 8. 4 in the case of n equal to 4, 8 would be the answer. Even if you just I just compile and run, you can have a look at it. So you'll be getting this. Yeah, this is for 3 and this is for 4. I'll just compile and run now. So yeah, it is 8. So why am I saying this? Because we are adding our previous values to compute the present value. So this is basically nothing but the Fibonacci series, right? So that is the reason and also we are adding current 1. Current 0 is current nth Fibonacci number, and current 1 would be the previous Fibonacci number. So we'll be adding these two and giving out the result. Okay, this is also one of the correlation with mathematics. The main thing is use of dynamic programming concepts without the use of extra space. So it's like space optimized dynamic programming. So the space complexity is O of 1 here and time block complexity is O of 1. Okay, I hope you people understood our approach, and let us even submit the code now so that you people can see the status. Okay, fine, it's working properly. Okay, so I hope you understood this particular approach, and if there are any doubts, please feel free to comment in the comment section, and the codes in Java, C++, Python are in the description. Please go through them, and yes, that's it. Well, thank you for watching, guys. Stay tuned.